Okay, this video is going to be on finding the acceleration of a block down a ramp when kinetic friction is acting. And if you follow the last one with static friction, it's very similar. So, and I did talk about it in class, but this is just for you to look at if you need to see it again. So again, you draw the sketch, you sketch all the forces that are acting. You got the normal force, get force due to gravity. In this case, you have the kinetic friction force. Alright, so in the x direction, the forces that are acting are Fgx and minus the friction force, and that difference is equal to the mass times the acceleration in the x direction. And this time there will be some sort of a value on the right, most likely, because the object is in motion. Although it could be in a constant velocity situation, that would be the only case where the acceleration would be 0. In the y direction, we have Fn minus Fgy equals 0. And it's equal to 0 because the object is not accelerating in the y direction. Same issues we talked about earlier. And if you wanted to find the components, Fgy, Fgx, you do it just the same as last time. I won't re-describe that other than to say Fgx is equal to Fg sine theta, and Fgy is equal to Fg cosine theta, where theta is the ramp angle, which also happens to be this angle here, right there. And Fg, by the way, don't forget, is equal to the mass times gravity. It's the easiest thing to forget now, pretty much. Alright, so I'm going to add to this set of equations just the one that you already know as well for friction. Fk is equal to the coefficient of kinetic friction times the normal force. Put on a new slide, and let's just solve these to get our value for acceleration. So we have, just remind you the equations up top here, Fk minus Fk plus Fgx equals max, and then I'll put in what these are equal to. I have the x direction here. I have that Fk equals mu k times Fn, which is equal to, and then Fn from the y equations, Fn equals Fgy, which equals Fg cosine theta. So this over here is equal to mu k Fg cosine theta. So then we could say that Fk equals mu k mg cosine theta. And if we plug that in up here, we have minus mu k mg cosine theta plus Fgx is Fg sine theta, or mg sine theta, equals mass times acceleration in the x direction. Now I can cancel out the masses, do that, that, and that, and I end up with the equation we came up with in class, that acceleration in the x direction is equal to g sine theta minus mu sub k times g cosine theta. And then if you happen to have 0 friction, that term would become 0, and you'd be back to g sine theta, which is the acceleration in the x direction without any friction. And if you do have friction, of course, the acceleration is going to be smaller than it would be otherwise for the block sliding down the ramp. Alright, so that is your pertinent result. Just know when and where it applies. Okay, that's the end of this video.